Okay, so what we got here, we've got the packet pulled up, the little worksheet. Make sure you have your study sheet packets with your flow chart out. You're always going to need that flow chart. You're always going to need that study sheet. That's going to be a big help to you. So make sure you got that. Make sure you're learning how to use it and kind of following along, because this stuff is not going to get easier. Packet. So what we have, step number one, question number one, because it's technically broken into 3 questions. What do they want from me?
Mole ratio.
Mole ratio. So I got to get the mole ratio. It's always going to be B over A. So they actually, not they, I made this. It's already set up. So notice the chemical I start with on all 3 of these, A, B, and C, the first chemical that I give you is going to be on the bottom, because chemical A, the one you start with, always goes on the bottom for mole ratios. So O2 is on the bottom, CO2 is on the bottom, H2O is on the bottom. Then the chemical I want to get into on all 3 of these is going to go on the top. And the real question is, what are they missing?
The numbers.
They're missing numbers. And where do I get the numbers from? The equation. And so the equation's already balanced. You can see there's coefficients there. And I just need to go in and put my coefficients in as my mole ratio. And so this first one, C4H10 over O2, what are my coefficients? Yeah, so 2 over 13. 2 over 13. Boom. And that's all I'm looking for. I'm looking for those coefficients in that balanced equation, and you need to put them into fractions. So O2 is always going to be a 13. It doesn't matter what part of the question you're on. At least for this particular question and this formula, O2 will have a 13 in it. CO2 will have an 8 in front of it. H2O will have a 10. So you just need to fill those in, which shouldn't be too bad. So 2 over 13.
13 over 8.
Yeah, 13 over 8.
What? Yeah, so good. 13
And 13 over 10.
Yes, sir.
Ooh, easy stuff. And just as a reminder, this always comes from your balanced equation, because that tells you the relationship between those 2 chemicals. Mole ratio is the only thing that switches chemicals. All the other stuff we do just changes your units but keeps you in the same chemical. So like for this top one, for every 2 of these C4H10s I need 13 of oxygens to match up with that. And so whichever way I'm going from O2 to C4H10 or the other way around, I'm going to have that fraction, 2 over 13 or 13 over 2. There's going to be some sort of relationship between those 2. So now I got to do number 2. Number 2 is the next problem. I got A, B, and C done for number 1. Number 2 is asking me for what? So what are they giving me to start off with, and what are they asking me to answer in?
Moles of KClO.
Yeah, they give me 5.5 moles of KClO3, and they're asking me for moles of oxygen. So I'm going moles to moles. I'm going from KClO3 to oxygen. That's my starting chemical and my ending chemical. Now, when you get these problems, if it helps you out, find the number that you're starting with and find that chemical that's attached to it and just write an A there. And that might help you remember that's chemical A. And then find your other chemical where the question is how many moles of O2. Write a B there. Now I know, doesn't matter what I do, if I come back to this later, I already know that's my A, that's my B. That helps me set this up. So in this first box here, what's the first thing I always need to write down? The number they give me. I need to start with the number they give me. So I'm going to put that in that first box, 5.5 moles of KClO3. KClO3. And that's always just going to be over 1. Just pop it over 1. And then so I have 1 space left before my equal sign. What has to go in that 1 space? So I'm going from moles to moles. It's got to be the mole ratio. So we're using that flow chart there to help us set this up. So I'm going from moles to moles. It's got to be a mole ratio. So I know it has to be moles on top and moles on bottom. It's got to be moles over moles because it's a mole ratio. And I want B over A. I want my top chemical on top, or my ending chemical on top, my starting chemical on bottom. So on top, I need moles of O2. And on bottom, I want moles of KClO3. And now, where do I get my numbers from? Just like up top. The coefficients of the balanced equation. What's in front of O2? Is a 3. What's in front of KClO3? A 2. So that is my problem. I have everything filled out now. My problem is 5.5 times 3 divided by 2. And the answer, I'm just going to put right there. I don't, listen. Hey, you get your own answer. We're helping everybody set it up. You can go through and do the math on your own. Put it in the calculator. If you want, remember what I said yesterday, and I'll get this on camera for the people at home. If you have a big problem set up, something I think most of y'all are finding a little bit easier. If you have a big problem set up, you're multiplying a bunch of fractions together, what you can do, make a fraction at the end, multiply all the top stuff together, multiply all the bottom stuff together, and just get one top number, one bottom number, and divide those at the end. That might help you out to be a little bit easier. So, okay, so we got 1 and 2. Let's do, is number 3 a grams to grams problem?
Grams to moles.
It's grams to moles. All right, well, let's do that, and then we'll do a grams to grams problem.
I meant moles.
So we get a little bit of everything. Nice. Yeah, we'll do 3 and 4. So let me print screen this and clear my annotations and delete that. Paste this. Bing, bang, boom. Ready to go. Okay, so now lights back out. Number 3. Let's take a look at number 3. So what kind of problem is this? Moles to grams. So something I can do to help myself out. What's my chemical A? Yes, it's K. K is going to be my chemical A. So the number they give me to start off with is this 0.563 moles of K. So K is going to be my chemical A. And then what they're asking me for, how many grams of KCl, which they give me the molar mass for, which is nice. I don't have to look that up. So KCl is going to be B. And I'm going from moles of A to grams of B. Now, another thing I can do when I set this up, just to make it a little bit easier for myself, I'm always going to start with my starting number, right? So let me go ahead and put that in. I got 0.563 moles of K over 1. I can write down what to do in these boxes from my flow chart before I get started. That way it's just a little bit more information for me. So if I'm leaving moles and going to grams, what's the first thing I do right here? Mole ratio. Because I'm starting at moles, I'm going to do the mole ratio first. And then what's the second thing I do here?
Molar mass, right?
Yes, and I multiply by the molar mass, right? So now just kind of made some notes that might help me out. I know what my chemical A is, and then I'm starting in moles. I know that my chemical B is KCl, and I'm going to grams. I know this has to be the mole ratio, and this I need to be multiplying by the molar mass. So now I just need to make that happen. So mole ratio is going to be moles over moles, a ratio of moles. I got to have B on top and A on bottom. It needs to be B over A. So I have KCl on top and just K on bottom. And then what are my coefficients going to be? Yeah, 2 and 2, because they're both 2. 2K, 2KCl, so 2 over 2. And then what do I need to do for this last part? Yeah, I need to multiply by the molar mass. I could look it up, but they did give me the molar mass for KCl right in the problem. So they tell me KCl is 74.55 grams per mole That's a molar mass. You could also look it up on the periodic table. Add up 1 potassium, K, and 1 Cl, and you should get 74.55 grams of KCl equals 1 mole. And just so you know, I put the 74.55 on top of that fraction because I'm multiplying. If it had been a different problem and I needed to divide by my molar mass, I take that number and I put it on the bottom, and I put the 1 on top. So now I have it set up. I can make myself a little fraction here and do all my top math and my bottom math separately. But yeah, you're just going to do your math here, plug everything in, multiply and divide where you need to, and you should come out with your answer. So actually, should we do another one? No, we'll set up another one because I'm not giving you the answers. You still got to do the math. But we're getting this set up, and then you'll have a couple more examples at the end because we're all about learning here, right? It's not just like turning you loose. So, but I want you to kind of tell me what to write down for this last one for number 4. So what's the number they give me to start off with?
7.1
Yes, so they give me the 7.1 grams of Na2O. So I know that's my chemical A. And then what do they want from me? Grams of NaOH. So how many grams of NaOH is going to be B? Notice in the parentheses, I gave you the molar masses for both of these, so you don't have to add them up from the periodic table. If you didn't have them, you would have to add it up, but you should be good right now. And we're going grams to grams. So we need to start by writing our first number down all the way to the left, and that's the number they give us, that 7.1 grams. 7.1 grams of NaOH. Put it over 1. And then we can also take notes. Now, I don't have a lot of room on the bottom of my board, so I'm going to put it up top. What's the first thing we need to do here? Going from grams to grams. I need to divide by the molar mass of A. Then what's the middle thing?
Mole mass.
Nope.
No, mole ratio.
Yes. Mole ratio is in the middle. And then at the end, I need to multiply by the molar mass of B. So those are my 3 steps. Those are the things I need to do. Let's go ahead and start to put them in. So what's my starting chemical? What's my starting chemical A? It's that Na2O. Oh, yeah, I wrote that down wrong. Y'all didn't even say anything. You're just going to let me do it wrong. So I have NaOH over here. It needs to be Na2O. Na2O. There we go. So now 7.1 grams of Na2O. So I need to divide by this molar mass. And they give me the molar mass, 61.98 grams. If I didn't know it, I'd look it up from the periodic table, add up 2 sodiums and 1 oxygen. Should be 61.98. So I need to divide by that. Am I going to put it on the top or the bottom? It's got to go on the bottom. So the 61.98 grams of Na2O goes on the bottom over 1 mole. Or under 1 mole, Na2O. So that 61.98 grams is equal to 1 mole. That's what goes on top. Anytime I got Avogadro's number or a molar mass, the other side of that fraction is going to just be 1 mole of that chemical. Now, what's in the middle here? Mole ratio. So remember, mole ratio is just moles over moles. I know it's got to be B over A because my flow chart tells me that. So I make sure my chemical B is on top, NaOH, and my chemical A is on bottom, Na2O. And what are my coefficients for NaOH and Na2O? 2 over 1. 2 over 1. And then lastly, what's the last thing I need to do? Multiply by the molar mass for B, NaOH. And so that's that 40 grams per mole. And that's got to go on top because I want to multiply by it. So 40.0 grams of NaOH over 1 mole NaOH. Nice! That's my problem. And so hopefully this has kind of simplified things a little bit. If you break it down, you got to know what's my A chemical, what's my B chemical, what's my starting point, what's my ending point. Am I starting at moles, ending at grams, or what? Trace that out on your flow chart and find out how many conversion factors you need. These problems with it already kind of set up like this, you know, I got my starting number and I got 2 conversion factors. But you can kind of write it down like we were doing. What are my conversion factors? What are the things I need to do? Well, on this one, I got to do all 3. I got to multiply by the molar mass of A, I got to use the mole ratio, and then I got to multiply by the molar mass of B, or divide at the beginning. But you know. So set it all up, then do your math. And remember, if you want to, multiply all the top stuff together and give me a top number. Multiply all the bottom stuff together, give me a bottom number, and then just divide top number over bottom number, and you should be good. That'll make your math a little bit easier. So if anybody has any questions, let me know. Try to work on it and see if you can get all the way through this. And then tomorrow we'll go over it a little bit more. We'll get everybody some answers, and then we'll be ready for the test, ideally Thursday, I guess. So, yeah, if you're at home and you see this video, first of all, congratulations. I don't think that everybody's watching the video. Yeah. Third period, say hi to Julian. If Julian watches the video. Yeah. If you're not in third period, don't look at that part of the video. That's not your class. And yeah, Rocky's there, and Elijah. Yeah, Eli's in there. Who else is there? Yeah, Presley. Presley's remote, and
What about this guy? Maybe Churro. Maybe Adrian right now. Oh, hey, Adrian.
hello. Yes.
Hey, maybe Churro.
Yeah.
What, this one? He's looking at me.
Okay, yeah. I'll bring him with me. Okay, no problem. All right, bye. Oh yeah, we're gonna do that in a second. Okay, so yeah, hello everybody at home. If you get stuck, email me. Send me a screenshot of your sapling problem. Let me know what problem you're on this worksheet, and I will get you some answers back to help you out. So thanks, and everybody have a nice day.